Let's talk about partial classes first. Say that you're on a project team where you're writing some of the methods in a class and someone else is writing the rest. You may find it helpful in this situation to use the partial keyword and split the class definition across multiple code files. Another great use of partial classes is to let you customize code generated, such as the entities created by Entity Framework. You can't directly change the generated code because if you ever need to regenerate the entity classes, it'll overwrite your customizations. Because the Entity Framework classes are implemented as partial classes, and in fact this is one of the major reasons why Microsoft added partial classes to the language, in that case you can create a partial class in a separate code file that's unaffected by regenerating the entity code. Here's the definition of a Customer5 class. Now, this class has the same properties and methods as the customer class. But this file contains the class constructors, the properties that identify the customer, and the methods to save and retrieve customer information and change the customer's location. The only difference between this and the customer class is that this class is defined with the partial keyword. So this is what's key to allow you to split the definition of Customer5 across multiple code files. So the scenario here is that you have one developer who's the subject matter expert on customers as far as the basic information about what kind of information our company needs to retain about them, where the data is persisted, whether it's XML files or databases, all the ins and outs of the base customer class. But then there's another subject matter expert who's responsible for financial information. So over here I have a partial Customer5, and this is the class file, the code file, that other developer is working on that has all of the financial information related to customers. So it's in a completely different file. It also uses the partial keyword. And so now one developer can be working on Customer5, making changes, updating, and so forth, and another developer can be working on this partial Customer5, and there's nothing fancy about the name. I just named that so that there's a correspondence between those two classes. What's important is that these both have the same definition of Customer5, and they use the partial keyword. Okay, so partial Customer5 has financial information as a property for annual sales and total sales. It has the record sales override method, record orders, all of this information that's related to a customer and finances. Okay, so the declarations are identical. And it's important to understand that you do need to include the partial keyword in both of the source files, or all of the source files if you have multiple files. Okay, so what happens is that when you compile the project, C# combines the code in the customer5.cs file and partial customer5.cs files into a single class definition. So at runtime, there is only a single Customer5 object within the application. So that's the other very important point to understand. We're not defining multiple classes called Customer5. We're defining a single Customer5 class that is blended together, essentially combined together at compile time. And C# takes care of all that for us, as long as we properly declare the class with the partial keyword. Okay, so to show that, I have this simple code here where I'm newing up the Customer5 class. I'm assigning a value to customer name. I'm recording sales. So I'm executing or I'm using code, property and a method, from those two different code files. But from this code, there's only one Customer5. It's a unified object in memory. So I'll go ahead and run this. And I'll select H. And you can see the customer is Biggie Industries. And if I go over here into my file, we have Biggie Sales right there that was just created. I can open that up, and you can see that we recorded that information. All right, so I'm displaying the name in the console window using properties that are defined in one code file, and recording sales that causes that XML file to be written out in the other code file, but this is all a single object in memory. So, bottom line is that someone looking at or writing this kind of code doesn't know that you separated the class into multiple source files. The code that uses that class, there's nothing here that indicates how that class was implemented. At compile time and runtime, that's all irrelevant, whether it's in multiple code files. The class contains the members that we added to it, and the calling code uses them the way we were intended, as a single object. So in the compiled code, there's a single unified customer5 class. Okay, so one small caution. Don't use partial classes as a solution when you have classes with large number of members, or classes with members that contain a large amount of code, and you're having trouble managing your code. Partial classes aren't a solution to that kind of problem. Rather, you should probably redesign your classes so that they're more manageable. Okay, partial classes, one way of organizing code, letting multiple developers work on different parts of it without any kind of conflicts. The two classes still have to be to result in a single good unified class, but it's a way of organizing the code. Okay, so now let's talk about nested classes. A nested class is a class defined within another class. Nested classes provide a way for you to organize members of a class so that they're easier to use at runtime. So let's take a look at customer 6. Okay, so this is another variation of the customer class, but notice that I have two class definitions here. So I have a class information and I have a class financial. The information class contains basically the information about the customer, demographic information, customer ID, customer name, and so forth. Okay, so you can see that I've essentially refactored the customer code into a couple of different classes. Okay, so I have a fair amount of code for information, and then I have all the financial related stuff in a nested class. Okay, so this has information about cumulative sales, annual sales, total sales, recording orders, and so forth. Okay, so what's important here is that I have this class definition, and then within the body of the class, I've created these other two class definitions. So these are nested within the body of the customer 6 class. So that's what makes them nested classes. Okay, so as you can imagine, this might make the code file fairly complex. Fortunately, Visual Studio has some navigation features that help you find and get at nested classes. Okay, so I'm currently within customer 6, but I can use this drop-down list right here in order to see all of the nested classes within this code file. And as you can see, I have the financial and the information. These are in alphabetical order, so they're not the order in which they appear within the code file. And as you can see, something I didn't point out is that then there's another nested class within financial, and that's called tax calculator. So this makes it really easy to navigate the different parts of the application. If I want to jump directly to the tax calculator, that will expand the financial class and take me to this definition as well. And so this is nested 2 levels deep into this hierarchy of class, these nested class objects. Okay, another thing I want to point out here is that customer 6, if I collapse all of this code here, there we go. Notice that customer 6 doesn't have any members of its own. All of the members of the customer class now are part of either the information class or the financial class. Okay, so if I come over here, notice that I have some code here. So I'm going to add a little extra code here. So what the implication of customer 6 not having any of its own methods is that I can do something like this. Customer 6, and hit the dot. Notice that there's a couple things that it gets because it inherits from system.object, but there are no other custom members of customer 6 itself. Instead, I have to use one of these classes there, so I can create an instance of the information class, and I'll call this cust.info, and that's equal to customer 6. I can go down there, dot information. Oops, forgot the new keyword. And that's how I need to instantiate that class. Now, if I use the cust.info object, let's see. Oh, okay. It wasn't, IntelliSense wasn't identifying that variable. It's because I didn't put the semicolon there. Pay attention, Donald. Okay, so now I can use that cust.info object, variable object that holds a reference to customer6.information. And now I can get access to all of the properties of the customer related to information about that customer. Okay, so that shows how you can use those nested classes. So I'm going to get rid of all this code. Whoops. Went too far. Okay. Getting a little carried away with my Control-Z undo. All right, so this is now code that exercises that customer 6 in a class. So as you can see, I can instantiate customer 6 on its own. I can't get access to any of its members this way, but I can get access to those two objects. And so I instantiate a customer info and a custom fin for the financial information. So now I have 3 different variables that have references to all 3 of those different objects. And then I can new up an information object directly and start assigning properties. I can, but in this case, what I'm doing is I'm using the information object within customer 6, and I have 2 different objects that now contain all of the information about Biggie Industries. And then I can read the data. Record sales, and that'll create the XML file. All the same kinds of operations that I've been doing with the customer class. Okay, let me go back over to customer 6 here. And as I mentioned briefly, that we have this tax calculator. So this shows a technique of using nested classes to include helper classes in other classes. Okay? So this code shows the structure of this tax calculator. It has an empty constructor, and in this case, I'm just going to find the tax for a particular state. In this case, our company just works in Washington, Minnesota, California, and Alaska, and so it has all of the taxes, the relevant taxes, presumably sales taxes, for the different states. Okay, so I nest this within customer 6, and specifically within the financial class of customer 6, because this is an object that's going to hold helper methods that are just going to be used within that class. So it's designed and created only to be used within the financial class. And what's kind of interesting is that it's declared private here, but the constructor is public. So what that means is that the tax calculator is not visible to any class other than the financial class. I can change that. I can make this public as well, but in this case I made it private because it's only going to be available for use within the financial class. Okay, so now if I select financial, I can go to record sales. And here's some code that shows how to use that tax calculator. So the code creates an instance of that tax calculator class. That works because this code is within the financial class, and it's private within that class, which means it's visible to the financial class. And I can instantiate it here because it's a public constructor. And then it instantiates an instance of the information class because I need to get the customer ID. And I'm going to use that to get the customer info from an XML file that I previously saved. And I need that information because I need to know the state where that customer is located. And so I use customer info to read the region, pass that to find tax, because remember, it's going to look up that state value, and then add it to 1, and then multiply that by sales in order to apply the tax to what the total sales amount is. Okay, and then the rest of record sales is pretty much the same. It's going to write that information out to a, whatever the name the customer ID is, _sales file. And this time, the sales amount that it's going to save is going to have the tax applied to it. Okay, I'll run the application. And I'll select I for nested classes. Okay. And then I can go over here once again to Biggie Sales. And this now has the tax applied to it.